Hello and welcome back to another session on cybersecurity. In this session, we're going to take a look at domain name system, DNS, and we'll see how it works. So let's take an example. Let's understand how DNS works with an example. Consider this to be my browser, which I'm running on my laptop. And in my browser, I'm going to type the URL of my website, codespindle.com. So I have hosted CodeSpindle, and I'm just going to access the pages with respect to codespindle.com. So this particular website is hosted on a server somewhere, and this server contains the pages corresponding to CodeSpindle. So now the challenge here is from my system, I should be able to access the pages from this server. The very first thing my system requires is the IP address. So let's say this is the IP address 10.02.01.15, some IP address we have. So to access the pages corresponding to CodeSpindle, what my system needs is the IP address of the server. See, systems communicate using IP addresses. So the very first thing we require is the IP address so that we can really contact that server and fetch the pages corresponding to codespindle.com. But the challenge now for my system is how to get the IP. How to get the IP address. So it should somewhere get the IP address of that server that's hosting codespindle.com. So how to get that IP address? For this, the solution is domain naming system. Domain name system, which actually helps us to get the IP for an URL. So somewhere there is this information stored. So for CodeSpindle, the IP address is 10.02.01.15. So there is somewhere this information is managed. So my system will first query this particular system holding this information so that it can get the response back with the IP. And using this IP, it can contact the actual server to get the pages corresponding to CodeSpindle. Am I clear with this? So what is the use of a domain name system? It maintains information about the URL and the corresponding IP. We can say the domain CodeSpindle and the corresponding IP. So my system will first contact this system to get the IP address, and using that IP address, it will contact that server hosting CodeSpindle to get the pages with respect to codespindle.com. So this is at a very higher level what a domain name system helps us with. It helps us with the IP addresses for the domains that we want to access. So now let us see how it actually works, how this gets resolved. So let's go to another slide. Let's start with this process. So I have my browser here, and let's take an in-depth look on how this DNS query gets resolved. So I'm going to type codespindle.com. So this is the address I'm typing. So once when I want to access this domain, I want the IP address for this domain. So for this, the very first thing my system is going to do is it's going to contact a DNS query resolver. So DNS query resolver. So this system will help us in resolving DNS queries. It is provided by our internet service provider. So this is our local DNS query resolver. So this DNS query resolver, what it will do is it will contact the root server. So there are many root servers available across the globe. So we denote the root server with a dot. So that's the root server. Let's say this is the root server, and the root servers, we have many instances of the root servers, and they are accessible using 13 IP addresses, and they are maintained by several organizations across the globe. So this root server will be the first one to be contacted by our DNS query resolver. So once when the root server is getting contacted, it is not going to supply us with the IP address. Rather than that, it's going to give us the contact for the top level domain servers. So it's going to give the DNS resolver the contact for the top level domain. So TLD. What do you mean by a top level domain? These servers maintain information about sites corresponding to .com. These are top level domains, .org, .net. Not only that, we also have country specific domains, .in for India, .uk, something like that. So these are all top level domain servers. So now .com, quote spindle .com falls under this top level domain server .com. So here it's going to give us information about the server which maintains information about .com domains. So now let's consider this to be our top level TLD, top level domain server that will maintain information about .com domains. So that is the info that it gives, and our DNS query resolver will now contact this top level domain server which is going to hold information about .com domains. These top level domain servers, we have many top level domain servers across the globe, and this is not going to actually supply us with the IP address. Rather than it's going to give this DNS query resolver the information about what is the information it is going to give. It's going to give us the information about authoritative name servers. We call that name servers. So now the job of a DNS query resolver is to contact the name servers. The name servers are the servers that hold the information about the IP mappings for our URL or our domain. So let's say we have name servers here. So name servers, we'll have this name server. I will represent this name server as NS1, name server 1. So now it gets the information about the name servers that contain information about the IP addresses of codespindle.com. So now our DNS query resolver will contact the name server. So it will contact the name server, and what name server contains is, name servers contain DNS records. So our name servers contain all the DNS records for every domain. So here the name servers will have the records corresponding to codespindle.com. So what kind of DNS records we have? Let me write it here. So we'll just talk about a few records. A record. So what is an A type record? It's a DNS record which will hold the IP address corresponding to a domain. So for instance, the website we are trying to access is codespindle.com. Say the IP address is 10.02.01.15, something like that. So this is an A type record. So it contains the IPv4 address mappings for a domain. So domain is codespindle and this is the IPv4 address. So this is a DNS record which is present inside our name servers. And what are the other types of records? We have quad A records. Quad A records again contain the domain codespindle.com, whereas it is mapped to an IPv6 address. So if your domain is going to be mapped to an IPv6 address, you'll have a quad A record. Other types of DNS records are MX record. What is an MX record? It's a mail exchanger record, and it is pointing to the mail servers. Say CodeSpindle provides me with a mail server which is identified as mail.codespindle.com. So mail exchange records, MX records, point to the mail server for that specific domain. And we also have other types of records like service records, which point to the various services and servers supported by that domain. And we'll have this is with respect to services and servers. And we also have text records. What is the use of a text record is it holds ownership information. See, when Google verifies your website, it gives you a certification. So that ownership certification information is provided in the text records, and this kind of ownership certification is required if you are using products like Google Analytics and Google Search Console, so that to identify that you are the owner of the website. So these are some types of DNS records. We also have SOA records. Start of authority records are mapped to the actual contact points or the administrators who are or in charge of managing that specific domain information on the name servers. So start of authority, A, quad A, MX, service, text, and there's also CNAME record, which is used for maintaining aliases. So if you create an alias for your domain, that will be maintained under CNAME. So all these are called DNS records, and all these records are maintained for a domain. So you have all these DNS records maintained for this domain, codespindle.com. So you're going to have this domain, and a domain can have lot of subdomains. What do you mean by a subdomain here? Subdomain. What do you mean by a subdomain? Say CodeSpindle can have subdomains like mail.codespindle.com, ftp.codespindle.com. So one subdomain is ftp.codespindle.com. Not only that, I can also create more subdomains like blog.codespindle.com, and other subdomains I can create like sales.codespindle.com. So there are subdomains for a domain, and also there are a lot of DNS records. So all these DNS records are maintained inside a file called as the, what is that file? A zone file. So we just have a text file wherein we are going to put all these records, and we maintain that under a zone. So we categorize these records under zones just for administrative purposes, so that we can have an administrator for these records. So it's easy to manage. So we have a zone file, and these records for a domain are mapped to a file called as the zone file. It's a text file managing these records. So you're clear with this? What is that we have seen now is what is the DNS query resolver, and what is a top level domain server, what is a root server, and what happens when you type an URL. So this query resolver will contact the name server, and this name server will use this type A record to send back the IP address. So what is the IP address? 10.02.01.15, which will be in turn given to our machine. So the IP address is coming back here. So using that IP address, it will be contacting the server hosting that specific website. So this is with respect to the flow, and there are certain more things we need to understand. Let me erase a few parts of this. Let's erase certain things here. I'm sorry for this messed up writing. I could have come out with some good diagrams, but due to time constraint, I was not able to do that. But I hope you are able to follow this. Let's get to this thing again. So we understood what is the name server. The name servers are the ones which contain the DNS records falling under zones and zone files. So we know what is a zone file. It contains information about a domain and its subdomains. So the separation of zones depend on how many domains and subdomains. What is the quantity of information you're going to have under a file. So it's just a segregation that we do for administration purposes. So where these DNS records are present inside the name server, it's present inside the zone file. So now all these types of records for a domain are present inside the zone file, and we have name server 1. Why did I give it as name server 1? Because we have multiple instances of name server. So we normally have minimum 2 instances of name servers. Say name server 2. What is the use of name server 1 and name server 2? It is used for managing any issues. Say if name server 1 goes down, name server 2 will be helping out with the queries. So what name server 2 has is an exact copy of the zone file. So these two servers, they are like replications. It's a replication of NS1 that is called as NS2. So we call NS1 the primary server, and we called NS2, what is this name server called? Secondary name server. So what is the use of primary and secondary name server? It's used for fault tolerance. Say if a primary server goes down, then secondary server will be answering the queries. So this zone file should be transferred from primary server to secondary server, so that the secondary server maintains an exact copy of the zone file. See, keep in mind, you can only update the DNS records. Update is possible only in the primary server. In the secondary server, we allow only read. So here we can read information, whereas if you want to update and read, you go with the primary servers. So this zone file, once when it is updated in the primary server, it should be transferred. So what we do is we do a zone transfer here, so that the zone file gets transferred to the secondary server. So what is the use of this fault tolerance? When this server goes down, we have a secondary server, name server, to help us with the queries. So you call this transferring zone file from the primary to the secondary as zone transfers in DNS. I hope you were able to follow this, and now we'll see what kind of attacks happens. And even before going into attacks, we'll take a look at this concept called DNS caching. What is DNS caching? That we'll see. So what is DNS caching? It's nothing but, see, now I have retrieved the IP after contacting the name servers. So I know the IP. So in the browser's cache or on the operating system's cache, I can store, okay, for codespindle.com, the IP address is 10.02. I'm just giving some example here, 01.15. So it is getting stored in the cache. What do you mean by storing that in the cache? Next time when I'm going to access codespindle.com, I'm not going to go through all these things. I'm just going to refer to my cache and then directly contact that IP address. So that is happening. So system, when you type codespindle.com, first it will check its own cache, the browser cache or the operating system cache, and then it will check if that IP is not present in the cache, it will contact the DNS query resolver to resolve things. If it is present in the cache, it will directly access that specific server using the IP address. Say, if it is not present in the browser cache or in the operating system cache, the next thing is it will contact the DNS query resolver. So the DNS query resolver will also cache that specific domain and URL. Say if codespindle.com, the IP is 10.02.01.15. So this is also going to have that cache, so that when you contact the DNS query resolver, it will check its own cache, and if there is an IP, it will provide you with the IP. Only if the DNS query resolver is not going to have the IP, it's going to contact the root server, and then it will proceed with the TLD and then the authoritative name servers. So I hope that is clear. That is called DNS caching. Now what kind of attacks can happen on a DNS system? The one thing that hackers can do is they can do cache poisoning. That is, they can manipulate the cache with their own fake IP addresses or with their own illegal IP addresses. Say, let's say it's for example 10.5.5.1. I'm just giving it. So this is the hacker's IP address. So next time when you wanted to contact codespindle.com, if the hacker poisons your cache, you'll be diverted to his own IP, wherein you'll be hosting a fake site in the name of Codespindle, and then you'll be able to capture your credentials. So what you call that to be DNS cache poisoning attack. What other kinds of attacks can happen? Say you're trying to query the DNS query resolver. The DNS query resolver contacts the name server, and the name server responds with an IP. So here, instead of the name server responding with an IP, the hacker can respond with his own IP, as if he is the name server responding. So he can give his own IP 10.5.5.1, so which can be diverted to you, and then you will be contacting 10.5.5.1, where the hacker will be running his own site and will be able to capture his credentials, capture your credentials. So what is this kind of an attack called as? It's called DNS spoofing. So we are spoofing the DNS server here. So we call that to be DNS spoofing attack. So how to prevent a DNS spoofing attack? Say somebody else is responding as if he is the name server here. So how to identify that he is not the name server? So to prevent that, we have DNSSEC, DNS security extensions. So what is the use of DNS security extensions is, it's like adding digital signatures to the response. So once when this particular primary server is responding, the message is encrypted. It is like digitally verified. Digital signatures are added. a signature is added to the IP address, just a public private key encryption that happens. So the information is encrypted and sent, so that when you receive it, you will be able to verify that it is from the legitimate sender. So that protocol, that kind of things are enabled only when you have DNS security extensions enabled on your servers. If DNS security extensions are not enabled, then those servers are prone to have DNS spoofing attacks. So that is the use of DNS security extensions. So with that, I hope you had a good understanding of how a DNS query gets resolved. Again, I'm sorry for this messed up writing on the screen. I had a lot of information to convey, and I hope I was able to put that information in a way that you can understand. So we started with the browser, we entered the URL, and then that URL is going to take us to the DNS query resolver. From there, we'll contact the root server. We'll get the information of the top level domain server. So here .com, so we'll be routed to the top level domain server. From there, we'll get the information about which name server holds information about codespindle.com. So we'll be contacting Codespindle's name server here. So that is the primary name server. So we looked at the various DNS records. So what are DNS records? These are records maintained for a specific domain. So for codespindle.com, we'll have all these records like start of authority, which owns the contact information for that specific domain, the administrator's info, and the mail that we have to send, to whom we have to send. So all this information comes under start of authority. So who is managing that zone, and a record maps to that specific IP address, the IPv4 address for that domain. Quad A record maps to that IPv6 address for that domain. MX records map to or tell us the mail exchange servers for that specific domain. And SRV records point to us like the various services and servers offered in that specific domain. So services can be like calendar services, address book services, there are many things like that. And text records holds information about the ownership certification for that specific domain. Say if Google offers you ownership certifications, and that string is mostly put up in the text records. And we also looked at subdomains. So say codespindle.com is the main domain. There can be many subdomains like mail.codespindle.com, ftp.codespindle.com, blog.codespindle.com, sales.codespindle.com, and so on. And we looked at two things, that is the primary name server and secondary name server. What is the use of having many name servers here? Just for fault tolerance. If one name server goes down, another name server will help us with the queries. So here we maintain all the DNS records for a domain inside a text file called zone file. And what is a DNS zone? We just categorize information in these files as different zones for easy administration purposes. And so here we have a zone file. Let's assume all that information for codespindle.com, the DNS records, are put up in a zone file. And this zone file is transferred to the secondary name server so that both these servers are in sync. They are updated together. So this is called zone transfer. That thing that we do with respect to this zone file transfer from primary name server to secondary name server is called zone file transfer. And we have seen that primary servers are the servers wherein we can update the DNS records and we can read DNS records. Secondary name servers or servers which will help us only with reading of DNS records. And then we looked at DNS caching. So once when we find the IP address from the name servers, we cache it in the browser's cache or in the operating system's cache memory. And we also have the DNS query resolver caching that specific IP address for that domain. So in case if you type codespindle.com one more time, you're going to first check the browser cache. If you find it there, you'll use that IP to access the server hosting codespindle.com. If that IP is not there, DNS query resolver will be used and it will check its own cache to check if there's an IP present. So it will supply that IP. If only the cache memory is not going to have the IP addresses, we are going to go with the root server, TLD server, name server contact. And we have seen finally what is DNS cache poisoning and spoofing. So cache poisoning is nothing but the hacker modifies the IP address in the cache with his own IP address, so that when you type codespindle.com, you will be directed to the hacker's system and you'll be running a fake website to actually capture your credentials. And DNS spoofing is nothing but whenever you get a response from name servers, an hacker can also send as if he is responding as a name server, and he can very well send his own IP address as part of the response. So you can use the IP address and you'll be diverted to the hacker system. So how you can prevent this kind of an response that he sends as part of DNS spoofing is, you can enable DNS security extensions, which is a layer which helps us with encrypting the information. So we digitally we have a digital signature for that information that's coming back, so that once when you receive the information, you can verify that we have got that response from a legitimate server. So that's it. That's how a DNS query is getting resolved, and I hope you had a good insight on how DNS works. In the next session, we'll be looking at how we can use the various tools like host, DNS recon, and nmap. We'll also see how to use DNS enum, dig, all these tools, DNS map, all these tools for enumeration, DNS enumerations. What is DNS enumeration? It's just getting information about the various records present inside the zone files and performing zone transfers. That we'll see in the next session. I hope you had a good time listening to this session. I hope you understood how DNS works. With that, we are coming to an end of this session. If you have any queries, you post that queries as comments. I'll be looking into the comments. That's it for now. Take care. Have a good day.